I'm Anil Kumar. I'm making a series on how to review polynomial functions. This is the first video in this series. We'll talk about polynomial characteristics and also discuss a few test papers. So I have 3 parts in this series. This is kind of an introduction. Then we'll have part 1, part 2, and part 3. Now, in this particular series, once we go through few characteristics of polynomials, you will be in a position to solve a test paper which may look like this. So have a good look at the test paper. These are few objective type questions. You can always pause the video, copy these questions. I will not answer these questions since most of the answers given here are correct, right? So take your time, copy the questions. These are very useful and important questions for you to review a few things about polynomials, correct? So I hope you've taken a note of these. Let me just turn the page over and share more from the same test paper. So you could have questions like this, right? So at the end of these 3 series, you will be in a position to answer any test paper on polynomials, especially if you are doing advanced functions in North America. This will also help you prepare for, this is a part of pre-calculus of course, and it will help you to prepare for many other tests, for example, SAT or AP Maths or things like that. I hope you find it useful, right? So this is one test paper. We can take many test papers. The questions which I am going to solve in this particular video will be different from these questions, right? So here are a few word problems for you, correct? So I hope it gives you an overall view of what you will be in a position to do after going through this series of polynomials, right? So this is one of the questions which we are going to discuss in this particular video, right? So in part 1, we'll take up questions like this to match the behavior and things like that. Now it's actually time to discuss. So let's now, without wasting much time, quickly go through what we know about polynomials. The idea is a review. So I'm assuming that this is the end of the semester, right? You know, but you might have forgotten a few things as you did this as the very first chapter in functions or advanced functions. So let's begin with the polynomial equation, which is given here as f of x equals to an x to the power of n, an minus 1 x to the power of n minus 1. Normally, we write the equation with highest degree first, right? So from here, we can read what the degree is, right? So what is the degree of this equation? It will be n, and what is the leading coefficient? Leading coefficient is an. Now these two are very important to actually characterize any particular polynomial. They actually give you the end behavior. When we say end behavior, we are trying to figure out that if x value is negative large, approaching minus infinity, what happens to y, right? And if x value is positive infinity, or approaching, I should say, then what happens to y value? There are very simple rules to follow and remember. So I actually follow just 2 rules for this. So I'll make 2 pictures for you. The first rule which I follow is kind of like this. If leading coefficient, we'll say leading coefficient is an. So if leading coefficient is greater than 0, that means it is positive. In that case, the graph is right side up. Do you see that? So we say in that case, the end behavior is that if x approaches, let me write down here, if x approaches positive infinity, y approaches positive infinity. Perfect. On the other hand, if an is less than 0, that means it is negative, then then the right side is down, right? In that case, the right side is down. Is it okay? When we say right side is down, it really means that when x approaches positive infinity, y approaches negative infinity, right? So that is the case when the leading coefficient is negative, right? So what we considered here is what happens to the characteristics when an, the leading coefficient, is being considered, right? The other part which we'll now look into is the degree. Now degree could be even or degree could be odd, right? It's not the function we're talking about. We are saying degree of the polynomial is even or odd. Now if the degree is even, so let me write down here about the degree. So if the degree is even, then we say both face same side. Both face same side. Do you see that? That is to say, if I have a polynomial which is, let us say, let me write down an example here. Let's say we write y equals to x times x minus 1 whole square times x plus, let's say, 2. Now this polynomial has a degree of 1, 2, 3, and 4. So in this case, degree is 4. So degree is 4, which is even. It has these zeros. One is at 0, one is at 1, the other one is at minus 2. Since the leading coefficient is positive, right side is up, and since the degree is even, both will face the same sides. Perfect. So if I have to sketch a graph, I know at 1 it is of 2 order, at 1 it is of 2 order, right? So this is at 1 order 2. But all others are linear zeros, right? So all others at minus 2, it is a linear 0, right? So it will just go, let me just draw like this now. Okay, and then it will turn like this. So what you see really is both face same ends. This is what we mean that even degree. Degree is even, both face same ends. I hope that point is absolutely clear. Now let me take up another example. When we say degree is odd, okay, then they face opposite ends. So for this, let me take an example here, and let me take an as negative. So I'll write the equation as y equals to negative. This means negative leading coefficient, right? And we'll just take example simple. So we have 1, 0 here, and let's say we have x minus, let me put x minus, let's say 2 square. So very simple example. The next one, we have a 0 here, but this 0 is of order 2. Is it okay? Now the degree you can see is 3. So here the degree is 3. Leading coefficient an is negative 3, correct? So that should be the end behavior. I mean, if x approaches infinity, y approaches negative infinity. Well, what happens when x approaches negative infinity? Opposite end means y will approach positive infinity, right? That is the opposite end we talk about when the degree is odd. Got it? So at 2, we see that the graph will bend, rather get reflected from the x-axis, right? So here the graph will get reflected, right? And on this side, this is a linear 0. It is going to go like this. So what you see here is a cubic function with negative leading coefficient, right? So I hope this part is clear, how we can relate degree and the leading coefficient and sketch the polynomial, and from the sketch we can always find the intervals when it is decreasing, right, increasing, and all those things, right? Well, so many questions we can answer. In this particular video, we will talk about, we have already discussed a part of it. Now we'll talk about finding finite differences, how to find equation of a polynomial from data, how to find equation of a polynomial from graph, and how to actually get equation from description. And we'll also consider even and odd functions, right? Okay, so let's move on. And here we have a test question on what we just learned. Take your time, pause the video, answer this question, and then look into my solution. So let's see how to solve this question. The question here is, what is the degree and leading coefficient of following, right? So that's first part, and part B is write their end behavior, correct? So let's begin with the part A. F of x is minus x plus 5x squared minus 6x cubed plus 10. Now what is the degree? So the degree here is, well, we have messed them up. You see the term with highest power is right there. So what you notice here, that as you will see in some of the test papers, that they will mix and try to confuse you. You have to take extreme care, especially in your test, about this part. So the degree is not 1, it is 3. So the degree is 3 here. And what is the leading coefficient? Let me write leading coefficient as an. Leading coefficient is the coefficient of the term with highest degree. So it has to be minus 6. Do you see that? Now, end behavior. We have odd degree. Odd degree means what? Odd degree means opposite ends. Is it okay? And leading coefficient negative means right down. Right side is down. Do you understand what I mean here? So let me use this space. Let's say A here. We'll sketch A here. So we'll not sketch the whole graph. We cannot without factoring. However, we can describe it. So right side down means this, and opposite ends means this. Do you get it? This is for part A. Can I write down end behavior now? Very simple. We can say if x approaches negative infinity, y approaches positive infinity. That is what it is. And when x approaches positive infinity, y approaches negative infinity. This part. You get it? Okay, now let's take up part B. So I hope you find it simple and useful. Now in part B, let me write here, what is the degree? How do you count degree when the function is given in factored form? You have to add them up, apply exponent rules. When you multiply, add the exponents. So the degree is 2 plus 3, 5, 5 plus 2, 7, 8, and 1, 9, right? So we get 1 plus 1 for this, plus 2 here, and plus 3 there, plus this 2, right? This is also 2, right? 1 plus 1, 2, plus 2, 4, 3, 7, plus 2, 9. Do you see how we count that? So degree is 9 for this. So 2, 5, 6, 7, 8, 9. So again, I've taken up an example with odd degree. Odd degree means opposite ends. This means opposite ends. Is that okay? Opposite ends. And what is the leading coefficient? Now to find leading coefficient, what you have to do is you have to consider all x's, right? All x's. Do you see that? Now positive, positive, positive. Negative cube means negative. so it is negative. So an is negative. Do you see that? So in this particular case, the behavior is exactly same as we did in the last example. Odd with negative. Do you see that? So the term will be again like this, and the answer is again the same thing. Do you get an idea? So I gave you two questions, but they have the same answer, and you should appreciate the trick involved, that I changed this position, made it negative, and at times you may do that mistake. Second, here's x squared. Don't treat this as one root. That will give you absolutely wrong answer. Okay, now since I took both like this, let me define a function g of x which has even degree. Okay, so I'll keep it simple. I'll say minus 2x to the power of 4, 3x plus 5. Okay, now clearly we have a function here which has even degree. Is that okay? And the degree is 4. Leading coefficient an is what? Leading coefficient is -2, negative again. So in this particular case, since the leading coefficient is negative, right side is down. Right side is down because it's negative. However, since the degree is 4, both face the same ends. Both face the same ends. So in this particular case, we have as x approaches negative infinity, y approaches negative infinity, and when x approaches positive infinity, y approaches negative infinity. So for both, it approaches negative infinity, right? So I hope you get it right. Now what I want you to do is write equation of the function which may have a graph shown like this. So I would like you to write a function which we have a graph shown like this. These are -5, this is -3, and this is 0. Perfect. Let's move on and do some more questions which are related to test problems. So here is the one where we'll have to find the finite difference and equation of the polynomial from the data. I'd like you to take your time, copy the question, try it yourself, and then look into my video. Now let's have a look at a test problem again. It is a very interesting question. The question here is, determine leading coefficient and degree to describe characteristics of the polynomial represented by the following data. So what we are given here is the value of x and y for few points. So that's the data given to us. What do we need to find? We need to find leading coefficient and degree. These two things. Once we find these two things, then we are going to describe the characteristics. These are the keywords to be done. Now how do you find leading coefficient from the data like this? That may be difficult at times. So the solution to this lies in finite difference. So what we will do here is that we'll find finite difference. So whenever the finite difference is constant, the level at which we will reach, that will tell us the degree. And the value of the finite difference will give us leading coefficient. So we'll develop that formula also. Okay. It is known to some of you, may not be known to all. So what we will do here is just make a few columns to find finite difference. So I'm just writing, drawing some lines randomly. I don't know what the value will be. But finding finite difference really means we'll do y2 minus y1. So we do kind of y2 minus y1. Always check that x values are in a proper order. It should be increasing by 1. So here the difference is plus 1. You see, minus 0 minus 1, 1 minus 0. And here we'll find the finite difference, and this is called the first difference. Okay, y2 minus y1. So we'll do that y2 minus y1 for all these values and place the value here in the column. So we have minus 8 minus 54. So 54 becomes positive. So I'll write 54 minus 8, which is not a good way to start since I just flipped it. Okay, but it gives me a value 46. Now let me do 0 minus 8. It will be 8. 6 minus 0 is 6. 22 minus 6 is 16. So truly speaking, I'm doing 36 minus 22. Okay, so 36 minus 22 is 14. And then we have 12 minus 36, which is minus 24. So we see that the first finite difference is not constant. So we'll just continue this process and then find the second finite difference. Is it okay? So again, the same difference, this y2 minus that. Okay, so let's do it once again. We'll do, 8 minus 46, which is negative 38. So we have negative 38 here. 6 minus 8 is negative 2. 16 minus this is 10. 14 minus 16 is minus 2. And 24 minus with that makes it minus 448 and 38, right? This is also not constant, so we'll just continue. We'll do the third finite difference. So this number is telling us we are doing the third finite difference here. Okay, so what do we get now? We have minus 2 minus 38, so 38 minus 2, in a way we get 36, right? 10 minus 2 becomes 12, minus 2 minus 10 becomes minus 12, minus 38 minus 2 becomes minus 36. Well, that is also not constant. So let's do one more. Hopefully we get it constant this time, and this is the fourth finite difference which we are doing. So we'll do 12 minus 36, this minus this, and that minus that. 12 minus 36 is minus 24. Minus 24 minus 12 is also minus 24. Minus 36 minus minus 12 is also minus 24. So what do you notice? So what we find here is that the fourth finite difference is constant. What does that mean? It means two things. One, degree is 4. Perfect. Second, what is the leading coefficient? an. Now there is a very interesting relation, degree, leading coefficient, and the finite difference. So the finite difference, if it is nth finite difference, then the leading coefficient is finite difference divided by n factorial. In our case, we are talking about the fourth degree, so the leading coefficient a4, n equals to 4, right, will be the fourth finite difference, which is minus 24 divided by 4 factorial. Now what is 4 factorial? Well, 4 factorial is 4 times 3 times 2 times 1. 4 times 3 is 12, 12 times 2 is 24. So we get a result minus 1. So we have a leading coefficient of minus 1. Do you see that? Now you can answer the last part of this, which is the characteristics of the polynomial represented by this data. What characteristics can you describe when you know the degree and the leading coefficient? From what we have learned so far, if the leading coefficient is negative, right side is down, correct? And if the degree is even, so it is even degree, right? It is even. Both same ends. Perfect. Both same ends. We know we have a 0 at 0, but more than that, we really don't have much information here, correct? Okay, so like this. So for the time being, I will just write the end behavior from here. That is what you can describe accurately. So the end behavior is when x approaches negative infinity, y approaches negative infinity, and when x approaches positive infinity, y again approaches negative infinity. Face same side. Perfect. Face same side. Now, from the data, it is very clear that it is negative in this half at 0, then becomes positive. It is increasing to 36 and then decreasing till 4. So if you look at the data and try to sketch your function, what can you say about it? So let's see. So what you're saying here is the function basically is kind of like this. Do you see this? But after 0, it increases to maximum. So it kind of goes like this, and then it has to turn back, correct? So that is the kind of graph which is being represented by this function. Do you see that? And that's 0. Now at 4 it is 12. That means at 4 it is positive, correct? So that 0 is actually between 4 and 5, correct? And here, since it is of degree 4, this seems to be a cubic 0 kind of a thing, right? That's why I've shown like this, not like a linear graph. Do you see that? So the order here could be 3. I'm not very sure of, but looks like. Perfect. So this is the kind of the graph which you expect from the given data. So I hope that makes sense. So I've packed up this particular portion with all what you need when you're given data and you're going to analyze the polynomial. And I hope that helps. So let's move on to the next part of this video. So in the next part, we'll take up a bit more about the leading coefficient and things like this. So have a good look at it, and then we will look into the other questions relating to the same topic, right? So here are two more practice test questions for you. I'd like you to pause the video, copy these questions. Is based on what we've learned so far. Question number 1. Determine the leading coefficient and describe the end behavior of the polynomial whose fifth constant finite difference is minus 60. So here we are given the fifth constant finite difference as minus 60. That means degree is 5. And leading coefficient an is, we know it is negative. Perfect. What is the value? How do you find the value? The value of an you can find by finding the finite difference, dividing it by n factorial. In our case, the finite difference is minus 60, and since it is 5 degree, we'll write it 5 times, 3 times, 2 times 1, and that gives you minus 60 over 5 times 3 is 15. I forgot to write 4 here. 5 times 4. 5 times 4 times 3 times 2 times 1. 5 times 4 is 20, 60, 120. Correct? Which gives us minus half. That's the value of an. Perfect. Now you know what the leading coefficient is and what is the degree, so you can describe the function very clearly. Let's look in question number 2. Determine the leading coefficient and describe the end behavior of the polynomial whose fourth constant finite difference is this. So we know fourth constant finite difference is 48, which is positive. So an should be 48 over 4 factorial, correct? Which happens to be 2. Positive, do you know? So same side, so we say x approaches positive or negative infinity, y approaches, since it is positive, up. Both sides this. Do you get an answer? You have to write end behavior here also. Correct? So I hope with this practice test question you gained a lot of confidence on what all we did so far. Perfect. Now let's look into another type of test question. Now here, determine a possible expression for f of x in which f of x is a quadratic function with following properties. F of x is greater than 0 on the interval minus 4, 1, and f of x is less than 0 on the interval minus infinity, minus 4, 1, 3, and 3, infinity. Pause the video, take your time, answer the question, and then look into my suggestions, okay? So I'll be there with you in a minute. Okay. Now let's see how to solve such a question. Now, my strategy here is to make a rough sketch, right? To make a very, very rough sketch. So I just make this axis and I call this as my working area. So this is my working area, okay? Okay. So let's see what we are given. Now what we are given here is f of x is positive in the interval minus 4 to, let's say this is minus 4 and this is 1. So it is positive here. So we are saying in this interval, okay, I don't want to really mess it up, but I want you to understand. So in this area, the function given to us is positive. So in this area, we're talking about positive values. Do you see that? And then in the other areas, it is negative. So it is negative here, it is negative here, here, here. But there is a critical point, which is at 3. So we'll write or show it like this, saying that this is 3, and at 3, it is negative. Okay. Now, can you determine the possible expression? Okay. It gives you an idea that the sign changes from negative to positive, that is the function, actually is kind of here and it goes up. And it comes down, but it has to change or do something at 3 also. So the best way I could represent the given information is kind of like this. So I could think about going from this side, crossing, coming back, crossing, and then this. Do you see that? So if I have that picture in my mind, f of x greater than 0 in this interval is positive, right? And negative all other intervals. Determine possible expression for the function in which f of x is a quartic function. Do you see that? That's why I made it like this. Quartic means degree 4. So when we say quartic, it means degree is 4. Perfect. And we should have something to correlate with degree 4, right? Now it is very simple to write down the function, and the function should be, there could be many answers for this, right? Since right side is down, an is less than 0. That means negative. Do you see that? First part. Now the zeros. X plus 4 takes care of the first 0 times x minus 1 takes care of the next one. Here we have a order 2 0 at x minus 3. Perfect. That is how you should be writing the equation. So does it make sense to you? So it says determine a possible expression. So that is the possible expression which describes the given conditions. So we are given two conditions, that is the intervals when the function is positive and the intervals when it is negative. I hope that makes a lot of sense. Feel free to share your comments, subscribe, and share my videos. That'd be great. Now here, we may take a lot of time to answer this question. We have a graph of a function. So I actually took it from one of the test papers which I showed you earlier. So I copied this question from here. Well, all the questions which we are discussing are from the test papers. Okay. Now, let's see. So the question here is, determine all possible, important thing is all possible, equations in factored form for the following. Octet means degree 8 for this particular function. Do you get an idea? So how do we do it? First, look at zeros. So we have 0 at minus 6. We have 0 at minus 2. We have 0 at 3. Then you look at order of 0. We know the sum is 8. So if I say that this order is 3, this order is obviously 1, then that term should be, to make it 8, that term should be 4. So that gives you one equation. So that is my first option for order. Second option could be, I could treat this as 5. Is that okay? This is 1. 5 plus 1 is 6 plus 2. Gives me 8 as total. That also makes it octet, right? So I have these two options. Based on the options, now I can write down my equation. And one more thing which we are given is a point. We'll call this point as point P. So we are given a point P whose value is 1. It's very small written here. 4, 1, 1, 6. That's the point P. Now that point will give us a specific graph. So it's not just a family. We're talking about a specific graph. Is it okay? So the first option of my function, let me call this as f of x, is equal to, we always begin with a, which we need to find using this point. Okay. So cubic at 6, that means x plus 6 cube, times linear at minus 2 means this factor, and at 3 we have 4 order. Perfect. That's my first option. To get the value of a, we'll substitute this point 1 and minus 4, 1, 1, 6. So 1 x is 1. That means a times 1 plus 6 cube times 1 plus 2 times 1 minus 3 to the power of 4 all this should be equal to minus 4116. You get an idea, right? So let's do our math. So we have 1 plus 6, which is 7. So let's say 7 to the power of 3, which is q, times 2 plus 1 is 3, okay, times. This is like minus 2 to the power of 4. So okay, you can write minus 2 to the power of 4. And let's see what this is, equal to 16464. So this is 16464. Okay. Now that is the number. So what is A equals to? A is equal to minus 4116 divided by 16464. Let's figure it out. So it's of course negative, and we have 4116 divided by 16464. That gives us 1 over 4. Perfect. So we get minus 1 over 4. Replace A with this. So we get f of x as equals to minus 1 over 4 x plus 6 to the power of 3 x plus 2 times x minus 3 to the power of 4. So I hope you find it interesting and very useful. It's not an easy question to solve in the test. Let me just tell you that first. Many students couldn't get it. Okay. Now let me write another function. Let me call this as g of x relating to the second part, degree 5. So we'll say a times x minus 6 is 0, so it becomes minus or minus, and degree is 5 times second one, linear at minus 2, which makes it positive, and then square. Okay, so we'll do square of at 3 x minus 3, and use the point P, which is 1 minus, minus 4116 to find a n. Do you see that? So I'll not do this calculation. I'll leave it for you. I hope you find it interesting. So do this calculation, get your result. Of course, it has to be negative since both sides are facing down. Now here is a very important concept. We'll now talk about even and odd symmetry. So the question here is, determine if the following functions are even or odd. We're talking about symmetry of function, right? Not degree. So let me define here what do we mean. So we try to figure out what is f of minus x. Now it could be either of these conditions. If it is same as f of x, we say that the function has even symmetry. If f of minus x is equals to minus of f of x, then we say that the function has odd symmetry. Anything else, if nothing like this, in that case we say neither. Right? Now, when I say the function has even symmetry, it really means that the function is symmetric about, let me write down, even symmetry means symmetric about y-axis. And when we say odd symmetry, then it has a point symmetry. And that is about origin. That is 0, 0. Is it okay? So that is what we mean by symmetry. Even and odd, that means this is same as y-axis. This is symmetric about the origin. To give you an example, let me just give you an example here of functions which could be having even and odd symmetry. The simplest function is x squared, right? So x squared here and x cubed. Even and odd. So this is even and this is odd. So that's a good quick review. Now let's look into these and figure out whether they have even or odd symmetry. So if I look at the equation, actually I can write down the answer. So from this I know it is even. From this I know it is neither. And from this I know it is odd. Okay? Now you have to algebraically figure this out. How do we do that? Here is the method. As explained here, you have to find what is f of minus x. Replace x with minus x. You get 3 times minus x to the power of 4 minus 9 times minus x squared minus 1. Now minus with even powers makes it positive. So we get 3x to the power of 4. This is also positive. So we get minus 9x squared minus 1. Now this is exactly equal to f of x, and therefore it is even. You get it? What happens in the next one? F of minus x will be minus of minus x cubed plus 2 times minus x minus 7. Now that becomes negative, so it becomes positive x cubed. This is negative 2x, and here it remains minus 7. You will notice that this is not equal to negative of that. Since this is negative, fine, this is negative of this, okay, but here we have the same sign. Okay, so it is neither. You could always treat constant as even. Constant is even term. So we have an even term here, and these two are odd. Do you see that? 3, 1, and this is x to the power of 0, which is even. That is why it is neither. And that is how I could give the answer. Now that is your question to test, and I'm telling you f of minus x is equals to minus of fx, and therefore it is an odd function. Does make sense to you? So with that, we come to an end of this particular video where we have discussed polynomial characteristics from its equation. We have mainly discussed how to find the degree, the leading coefficient, and equation of polynomial from given conditions. I hope you find it interesting. Go through my part, the other 2 questions of this polynomials, to understand more characteristics, solving polynomial equations, transformations, and some word problems. Thank you and all the best.